So we're using the ratio test, which means we need a what? So we need a n plus 1, which is, in this case, oh wow, n plus 1 to the n plus 1. They really just ask some fun questions at the end, don't they? Over n plus 1 factorial. Now, that is going to give you, up top, n plus 1 to the n times n plus 1. Right? Again, if I have a plus 1, the exponent, I could just multiply it by the base and get rid of the plus 1. So it's just like saying 3 to the n plus 1 is equal to 3 to the n times 3. Same concept. All right? And then on the bottom, you're going to have what? N plus 1 times n factorial. Now, the nice thing is n plus 1 and n plus 1 will cancel. So n plus 1 to the n over n factorial. Any questions on that part? So we take the limit as n goes to infinity of n plus 1 to the n over n factorial times the reciprocal n factorial over n to the n, which is going to give you, because that cancels, n plus 1 to the n over n to the n. Now, the interesting part about this, okay, and yes, I did say the interesting part about this, so this becomes a limit as n goes to infinity. We can actually simplify this all as one fraction, right? Because they're both raised to the n power, we can write this as n plus 1 over n to the n power. Correct? Which you can write as the limit as n goes to infinity. What is n divided by n? 1 plus 1 over n to the nth power. What is this? You may not recognize it because it's not something you've actually had to do before, but maybe they've shown you that this is e. That's where e comes from. All right? Now, is that greater than 1? So if it's greater than 1, this what? Diverges. Now, do you really have to show that that's equal to e? No. If I have n plus 1 to the n power over n to the n power, that means my numerator will always be higher than my denominator. So it diverges. That limit as n goes to infinity of 1 plus 1 over n to the nth power is the value of e. Easy way to show you, if I could, but I can't because my calculator doesn't go beyond 4 on the table. If you put that in your calculator, if you put 1 plus 1 over n to the nth power, and you just keep scrolling down, you'll get closer and closer and closer to 2.718, which is e. Yeah, again, the other way to show this is the fact that your numerator will always be higher than your denominator. So, because you'd end up with what? If you started with 1, you get 2 over 1 to the 1 power, and then you start with 2, you get 3 over 2 to the second power, and then 4 over 3 to the third power. No matter what, your numerator is going to be bigger than your denominator. So it has to diverge. It will never be smaller. Your numerator will never be smaller. So, any other questions? All right, then let's go ahead and get out our notes. Do this. You 10-9. So today we're talking about absolute or conditional convergence. Okay. So three possibilities with regards to the series n goes from 1 to infinity, and then dealing with convergence or divergence. One, right? The series converges absolutely, okay, if the sum of 1 from infinity of the absolute value, but this is absolute value, converges. Then the original series also converges. So if the absolute value converges, then the original series also converges. It's what's considered convergence absolutely. Now, other books also phrase this as absolute convergence. So they just put it backwards. And spell with English language. Right? Same thing with conditional convergence. Conditional, they call it conditional convergence. So if you see that whether forwards or backwards, it's the same thing. Now, a series only converges conditionally if the absolute value diverges, but the original series converges. And it is just divergent if both diverge.
So when we need to like figure out if it converges absolutely, if they like explicitly this to determine would that make sense?
You mean that basically we know that both the absolute value and the original function converge, then it converges absolutely.
But like we don't always have to like check if it converges absolutely.
No. You'll be asked. Find if the series converges absolutely, converges conditionally, or is divergent. If you see that, then you have to do this process. The nice thing about the absolute is if I do take the absolute value, what is this going to become? Do I need the negative anymore? No. 3n over n factorial, in which we are going to do the ratio test. Oh, by the way, if if we do the absolute value test, basically the absolute value, and we get that it converges, we do not have to check it. Okay? If the absolute value converges, then the original function also converges. It's what's called converges absolutely. But if the absolute value diverges, then we need to check if the original function converges or diverges. If it diverges, then we're done, divergent. But if it converges, it's called conditional convergence. So, ratio test. We know a n plus 1 becomes 3 to the n plus 1 over n plus 1 factorial. For those who weren't here Friday, this is what we did on Friday. Okay. Then we are going to take the limit of a n plus 1 over a to the n, the original function, which is usually easiest as writing as a multiplication of the reciprocal. So we get 3 to the n plus 1 over n plus 1 factorial times the reciprocal of our original function, n factorial over 3. Limit as n goes to infinity. Now, 3 to the n plus 1 can be written as 3n times 3, right? Times n factorial at our numerator. At the denominator, n factorial will be written as, or n plus 1 factorial is n plus 1 times n factorial.
What is that?
And I'm writing very small, there's not really here.
Is that n factorial on top?
Yeah. just like with dots, usually. So a little note for those who weren't here, anytime you see n plus 1 factorial, we can write that as n plus 1 times n factorial.
You just say it goes like n plus 2 factorial, like
It would not be, because then we'd write that as, again, factorial means we multiply it by every descending value. So what's the next value under n plus 2? N plus 1. So we go from n plus 2 to n plus 1, then to n factorial. Which we did have to do that, so good question. I think I posted the videos. I had to check that, I'm not sure. Friday, and usually that kind of went out of the other day. So there's a dumb quiz there, right? So, so what cancels out?
and we had
So the limit then goes to infinity of 3 over n plus 1. Now, the limit as n goes to infinity of this is basically your horizontal asymptote test. Okay, what's the horizontal asymptote for this?
business.
It's 0, because if your denominator has the highest degree, your horizontal asymptote is automatically 0. Okay. If they have the same degrees, the ratio of leading coefficients, if the denominator is, the numerator is has a higher degree, then it's infinity. That's your three options, either it's 0, ratio of leading coefficients, or infinity. And again, we went last semester, I know it's been a while, we showed you why that works, because you take the highest degree of the denominator, divide everything by that, and then you run n through, or run infinity through, and we would end up with 0 over 1 in this case. So this gives me 0. Now, the ratio test says if my limit is less than 0, it converges. All right. If it's greater, sorry, not less than 0, less than what? Less than 1. So since 0 is less than 1, this converges. If it's greater than or equal to 1, it diverges. A lot of these will equal 1.
If we include one duration.
That's right. Inclusive, that's right. So yeah, if it equals 1, it's inclusive. We basically find another test. Okay. So now, since this converges, we do not have to do any other, to check anything. This, since the absolute value converges, this converges absolutely.
Is there a way to determine what test you should like start off with, so you know, like get all the way through the test and then get
Usually you have to look at what we're given, like, why did I automatically do the ratio set for this one?
we had
We had a factorial.
Ratio to some fact.
There's situations where you don't, if it, like, you can do it without the factorial, but if we have a factorial, that's the only type of test we've seen where if you have factorial, you do this test. I think we did ratio tests with other ones without factorial. Look at the notes. But other stuff, like other things, you can say it's a p-series test or an in-term test. So there are other things we've done. Interval tests, limit, ordinary comparison tests, limit comparison tests. But yeah, there's a lot of tests, and I think it just depends on the situation. So in this case, let's say in this one, again, I take the absolute value, which means this is going to become the sum as in goes from 1 to infinity of just 1. Why? Where does the exponent go? Why did the exponent go away here?
we just want
Even
to
though
power.
it's not alternating.
Yes. So it becomes now it's no longer going to be alternate because it's going to be positive. Okay, 1 to any power is going to be 1. So you don't have to have the exponent anymore. Now your denominator you can write as n to the 1/3. What kind of test do we want to use as this?
Yeah, alternate.
Yeah, alternating series. Well, no. We don't have to do any test because this, what kind of series is this? P series. What do you know about P series?
Good diversion.
This, yeah, so since P here is equal to 1/3, which is less than 1, this diverges. All right, so we do know that this is not absolute convergence.
I understand this. And we're trying to.
Just be regular diversion, because we already know the data in diversion, so if we can do it. Cool.
Well, right now, we just know it's not absolute convergence, because we know the absolute value will diverge. Okay, if the absolute value diverges, then you look at the original function. Now, since this is a alternating series, we know what we need to do, which is a alternating series test. So, using our all series tests,
Yeah.
what do we do for that?
That's.
Right. There's two things we're gonna check for. One, we already know it's alternating. We don't have to worry about that. Does the limit as n goes to infinity of the function equals 0?
Looks like.
Oh, wait, yes.
Yeah, because the degree is bigger in the denominator, technically. If I put infinity in for n, I get 1 over infinity, right? Which is what? 0. So yeah, that checks. All right. Step 2 is a of n decreasing.
No.
All right, let's plug in. 1 over 1 to the 1/3. Okay. 1 over 2 to the 1/3. 1 over 3 to the 1/3. Is your denominator getting larger?
No, it's not.
Hmm? It's getting your denominator is getting larger, which means the whole thing is getting smaller, yes. Yeah, but your denominator is getting larger, which means your fraction is getting smaller. So this is decreasing. Now, if the limit goes to 0 and it's decreasing, then what do we know?
It's alternative.
So this converges.
Alright,
Since this, the absolute value diverges and this converges, that means this converges conditionally. Same setup, same absolute value.
One.
Now, these are a lot of alternating series, right?
Yes.
So most likely, if this diverges, I'm going to do another alternating series test. So this gives me the sum as n goes from 1 to infinity. This right here just goes away, right?
Yeah.
All right, so we just have n over n plus 2, in which we do an nth term test. How do I know I'm going to do an nth term test? Because I have a function of n over a function of n.
N plus N.
That's because I'm not thinking like that. So, in-term test. What does in-term test do? Limit any of n over n plus 2. Okay, which in this case does give you 1. What does it tell you? Yeah, because this doesn't equal 0, this diverges. If it equals 0, we were inconclusive. In-term test is only for divergence.
Okay.
Yes, that's where the chart helps, yes.
Can
All right.
you explain how that equals one?
Okay. There's a couple ways to do this. There's the calc way, which is to take the limit as n goes to infinity. What's my base degree in the denominator? 1. So we divide everything by n to the 1. Remember doing this last semester?
Okay.
All right, which would give you the limit as n goes to infinity of 1 over 1 plus 2 to the n. And if I plug infinity in, I get 1 over 1 plus 0, which is 1. That's the calculus way of doing it.
Wait, so this,
The alpha 2 way of doing that is what's the horizontal asymptote? If they have the same degree, it's the ratio of leading coefficients. So what's the leading coefficient at top and bottom? 1. That's the alpha 2 way of doing it. Again, yeah. So the calc is there to show you why it works, but you don't have to do that. So you only had to do that last semester. Yeah, well, you can just say we know this equals one. Alright, so we erase this.
We just say no equals one.
Yeah, that is.
Not our test, I mean, on like the big.
Yeah,
thing.
they would not expect, they would not need, unless they're saying, prove this. They're saying, prove that this is equal to one, then yeah, you need to show one. But if they say, if they're doing series tests, no. We don't have time for that.
Is
You
that,
just say that this equals one, and we done.
if it doesn't equal zero, is that the same for the comparison test?
Conditional test is different. Interim test is specifically for divergence. Comparison test, we can compare for convergence or.
Mm,
You have that chart?
Yeah.
Keep that chart. I have an issue.
mm,
Wait, maybe we should laminate it. So,
The end-term test can only prove divergence, right?
yeah,
And then the other ones,
you can do convergence on that.
okay.
Or sometimes it's convergence and inconclusive, and sometimes. Yeah, it depends on the test, depends on the situation.
Yeah, is that not the same thing?
So,
Exactly, that's why I don't understand.
So,
Well, it,
we could use the chart on this
that's good.
mid-unit test.
yes,
I guess I
Can
would
we use it
too.
on the end of the unit test?
it probably won't apply as much.
Keep it
Oh,
up around that. Yeah. I think this, we're gonna just have.
There's nothing about Taylor series and Maclaurin series and parabounds on there. Yeah, this is just for this.
It's not.
Well, you want to have it just, it's nice. Go ahead and probably help you.
We'll see.
Yeah. All right. So now if we do, now so that's because we show this diverges, we know if this converges conditionally or diverges. Now, why can't we do an alternating series test? Because what's the first thing we need to show for alternating series test? The limit of the function goes to what? Zero. Does it go to zero? No. So we can't do an alternating series test. We also do an interim test. So we take the limit and then goes to infinity of -1 to the n times n to n plus 2. Now, let's just write out what happens if I plug in 1.
Is this test all of the twenty
Yeah.
or are there different response?
I'll get A1. Yeah. So what's going to happen is this is going to go -1, 1, -1, 1, -1. So what is the limit?
One.
Does not exist because it does what? It just jumps up and down. The limit does not exist. It doesn't approach any specific value.
Which means it diverges.
It means it diverges completely. So this just
The right answer.
Wait, you said you plugged in one though?
when we take if you do the limit of the second part, because we know that this limit is what? 1. And as you go to infinity, it's going to go from -1 to 1, -1, -1, -1. It's just going to bounce up and down. So, I wonder what that would look like.
Thank you. Like. Really should find that person. It's not.
Now, do you guys want to try 4 and 5?
No. Oh, right now.
Try 4 and 5. Wait, well,
I don't even know where to start. All right.
All three.
It's a prayer.
value to help me goes away. So
Right.
a little help here on number 4. Once you get to value, you will do a ratio test.
After we go epsilon or for the
And you want to write small.
okay, I don't even remember what's happening.
I give you a couple minutes.
Maybe multiple variables.
So let's look at these, because I didn't read the directions very well. What do the directions say?
Oh.
The x value that makes the series converge absolutely. Now, when would this converge absolutely?
When it's greater than less,
When what? The limit of the absolute value of this is what?
less than one.
Less than 1. So we're going to do the absolute value of this. We're going to use the ratio test. All right, so the ratio test. We take the limit as n goes to infinity of the absolute value of. Now again, for the absolute value, what's going to happen to this?
As well.
It's going to go away. So I'm not going to worry about that at all. Okay. So n plus 1 times x plus 4 to the n plus 1 over 6 to the n plus 1.
Figure it plus one.
Why are you writing x less than?
Ratio test.
That is not correct here. Or I think not.
Right. Now, what do we do? We multiply by the reciprocal of this, right? So 6 over 6 to the n over n times x plus 4
Yeah.
to the n.
2, then I'll
Make sure that's less than 1.
so I did that, made that. I should. No.
Yes.
No, because it's one. Okay. I should x plus 4 over 6.
Now, what do we do with x plus 4 to the n plus 1?
Oh, you separate up.
To the n times x plus 4, right? Because again, if I had 3 to the n, at n plus 1, I can write that as 3 to the n times 3. So x plus 4 to the n plus 1 is x plus 4 to the n. That's x plus 4. Times 6 to the power of n, right? That's my numerator, everything in my numerator now. My denominator is 6n times 6 times n times x plus 4 to the n. Less than 1. Now, what nice thing is going to happen?
Why do you still have the absolute value there if you already took it out?
Just since I know the negative 1 to n power is going to go away, I just did not include it. I did not take it out of the absolute value yet.
But you did.
No, I just didn't worry about the negative 1 to the n power.
Right, but it's not there, then you took it out.
I did not take the whole thing out of the absolute value. I just know I don't need it because it's going to become what? Positive. It's irrelevant because it's inside an absolute value. No. Negative 1 to the n is irrelevant.
Oh,
I'm not spelled irrelevant.
don't go to children.
Probably just 1L. Inside an absolute value. All right.
I just said that one. Why does it not come back? Even though it looks like.
What happens to absolute value of positive 1?
I don't know.
1. What happens to absolute value of negative 1?
I don't know.
What's 1? What's 1 times anything? 1. Or no, 1 times anything itself, so it doesn't change anything. So the negative 1 to the n power would not have any effect on this function if it's inside an absolute value.
This other one's still, and then oh.
And it also can't itself.
So it's the local variables.
Just go away. All right, now, what cancels out?
Sorry.
6n, x plus 4 to the n. Right.
Oh.
So, what I'm left with is the limit as n goes to infinity. Now I'm gonna do something a little interesting here. I'm gonna separate this as 2 fractions.
X over.
N plus 1 over n times x plus 4 over 6. Yeah. What do you think that reason is?
N plus 1 over n cancel out to nothing.
It just becomes 1. The limit as n goes to infinity of that is what?
1.
1.
But we're so right.
Equals 1. Or sorry, becomes one. Oh, into the right. So I just can't. One. As you take the limits in goes to infinity of that, it's going to just become one. So it's going to just go away. So really, all I'm worried about, now again, since the limit is n goes to infinity, does the other fraction have n in it at all? So can we just drop the limit now since we don't have n anymore?
Yeah.
Yeah. So now your question is, number 2 question. When is the absolute value of x plus 4 over 6 less than 1?
When n is less than 1, less than or equal to 1.
When
Or less than 2, I'm sorry.
is x plus 4 over 6 is less than 1, and it's less than, and x plus 4 over 6 is greater than negative 1. We're doing absolute value inequalities years ago when you were probably freshmen or 8th graders. And yeah, it was hidden. I don't know. So which means multiply by 6, x plus 4 is less than 6. Subtract 4, x is less than 2. X plus 4 is greater than negative 6. Subtract 4, x is greater than negative 10. So for what values of x does this converge absolutely? Between negative 10 and 2.
Wait, so how did you go? Why?
Oh. So the reason we put n plus 1 over n is because we know that's going to become 1 when we take the limit as n goes to infinity. So, and there's no other n in the second fraction. So that just becomes 1 times the absolute value of that. So x plus 4 over 6. So,
Do we have to try it without with absolute value?
no. Because again, we're assuming that this converges absolutely. We just don't know what x values would that work for. So only for these x values, if x is in between negative 10 and 2, would this converge absolutely. Anywhere outside that value is no longer converge absolutely.
Was. Why did you keep the absolute value all the way there? Why did you keep the absolute value all the way there?
This question isn't does this converge absolutely or conditionally or diverge? This says when does this? And it would converge absolutely when we know the absolute value of the function, the limit, and then goes to infinity of the absolute value is less than 2. So with that, try number 5. Same concept. Try number 5. You're going to do the same stuff, ratio test and everything. Yeah.
Is this a ratio test here?
Yes. Yeah. Yes. Oh, wait, you need this too.
This is the homework.
No.
Review.
Yeah. So we're going to do the next 2 days. Just figure you guys can have it. Since you guys seem to be done with this one, so let's.
No, wait. Wait. We didn't have to. Wait. Just 2. Only 2.
0. 0 to be.
Format them in the lowest number less than x, not, is it less than what? Is it less than writing or?
Less than. Yeah. So if you want to do just interval like 0 to 2, that's fine.
Okay, that's what I was. Why did you get 0?
Because again, you have when you do the absolute value of inequality, you set it equal to the positive, and then you flip the sign negative.
So.
So that's what we did.
I didn't write the negative, okay, I just didn't write the.
So we do the same thing. Same thing here. We're gonna do the absolute values of the limit as n goes to infinity of the absolute value of again, a of n, so x minus 1 to the n plus 1 over n plus 1 times n over x plus 1 to the n, which gives me the limit as n goes to infinity of x minus 1. Now we'll do that. Minus 1. So x minus 1 to the n times x minus 1 times n over n plus 1 times x minus 1 to the n. Now the only thing that's going to cancel here is that one thing. So we can rewrite that as limit as n goes to infinity of x minus 1 times n over n plus 1. Now this is where we can separate this out. Limit as n goes to infinity of n over n plus 1 times x minus 1. Again, this should all be, keep forgetting x, less than 1, less than 1, less than 1.
So what happens when once we get to n over n plus 1, do we just get rid of that?
Okay, what's the limit? This goes to infinity.
What?
It's 1. So this becomes just 1, after value of 1 times x minus 1.
And the limit as this one approaches negative, or this one approaches positive nothing, right?
It's 1. So that's what we get. We get the limit. If you take the limit through that, again, we're only taking the limit as n goes to infinity, right? Not x, same x, just as n goes to infinity, which means we only worry about that one fraction, which since we know that goes to 1, we can drop the limit.
So it equals 1?
So yeah, that equals 1.
That's actually.
Yeah, but that if this becomes
You
1.
might actually not be here.
So we drop that down, drop that down.
Yeah, I see that.
So from here, we have x minus 1 is less than 1, and x minus 1 is greater than negative 1. So x is less than 2, x is greater than negative, or greater than 0. I said 2 and I wrote 1. Now again, if you want to write this as interval
Okay.
0 to 2, all right, you're good.
So you can you distribute up the limits, like take the limit of the left times the limit of the right? Would that be like, can you take the limit separately, the two fractions would take the absolute
It
value?
wouldn't make a difference because the limit only applies to n.
But like I'm okay to do that, then we just make one.
Like what?
When you provide equals limit
I'm not kidding you, I might fall over. I'm being incapacitated.
Well, there's no n in that second, so there'd be no point in writing.
Okay.
Now I'm going to ask you a question. It's on your list.
Do that.
When does this converge conditionally?
When after the value of a of n diverges, but the original series converges.
This step.
I'm putting off the fun. I also want to solve this out.
Right.
Wait, so. You just do it. So this is just converging, right? Or
So this right here,
is
it converges absolutely on the interval between 0 and 2. So the question asked now is where does this converge? That's
Well, but it says where it converges actually one line.
Where you just add
Yes, it did. Is that a different thing? So converging absolute sum, right?
That, the absolute value is, right? Like convergent, conditional, and the absolute values. Divergent.
Where does this diverge? At 0 and 2, right?
Yeah.
So we're gonna just check the endpoints. That's it.
How do we check the word test?
Plug it into the original function.
Let's see what question.
So we are going to check the endpoints. So x equals 0. Start with x equals 0. We're just going to plug in 0 for x in the original function. So to do that, we have from n equals 1 to infinity. What's 0 minus 1? Negative 1 to the n power over n. What kind of function is that?
Geometry.
That's an alternating harmonic function. Or harmonic series.
I need to write that. What's a harmonic series again?
Just one over n.
And it always diverges.
Yeah. Harmonic series always diverges, but an alternating harmonic series does what? Converges. So we already know that this converges. This is an alternating
That makes it conditional or?
harmonic. So converges. So right here, x equals 0, it converges conditionally. Because at 0, we know it does what? It diverges. The original function will diverge. Okay, or the absolute value will diverge. Okay, but the original function will converge.
So is it only for those 2 points or is it for all points outside of that?
No, just check the 2 inputs. So if this is 2, what do we get? What's 2 minus 1?
1 over n.
1 over n. We know that's what?
Harmonic.
In a regular harmonic series.
Divergent.
In a harmonic
Right.
divergence. So only show. That's the right word.
Out here.
Convergence at x equals 0. Alright, so have your homework tomorrow. Come in the homework questions if you have them, and we'll start working on the review. Right.
Is it? There should be lots of. I think that's a joke.